Hello mathematicians, and welcome back to Mathematical Proofs. This is the third video and we are again kicking it up a difficulty level compared to the last video. So in this one we are back to given a proof and no given. So I want to prove that the diagonals of a rectangle are congruent. So this is indeed true, but again we are assuming it is not true and we want to try proving it our own way. So over here I drew a little photo on the side. So as you can see, the diagonals are AD and BC. So that is my goal. I'm going to write that over here. My goal is I'm trying to prove that the line AD is congruent to the line BC. Now I went over here and I went ahead and made bigger our rectangle. And I just want to show you guys my thinking. So I can see that we clearly have two triangles being created by these diagonals. So I pulled out this blue rectangle over here. Blue triangle. I'm sorry, you guys. I don't know my shapes apparently. And then I also pulled out this red triangle over here. So I am trying to prove that this line is congruent to this line over here. So what I'm thinking is if I can somehow prove that these triangles are congruent, then it would follow that their sides are also congruent. So let's go back to what we know about proving triangles. I can either prove them by saying that all sides are the same. Well, I can't do that, right? Because I don't know what one side is. Defeats the purpose. I can do this by proving side angle side, angle side angle, and angle angle side. So let's recap on what we know about rectangles. We know that the four angles are right angles. The diagonals are congruent. Of course, we can't use this. It's what we're trying to prove. And that we have some isosceles triangles. So I'm going to come over here and just fill in the information that I have. So I know that this angle is our right angles, right? We just read it and we can use that. However, another thing I also know is that with the rectangles, I know that opposite sides are congruent, right? So this side, angle C, is congruent to BD. And similarly, I know that this side AB is congruent to CD. So I'm going to say that AC is congruent to BD. So this is X, then this also has to be X. And if I know that this bottom side is Y, then this is also Y because this is CD and CD. They're sharing a side. So let's see what we have. We have a side, an angle, and a side. We have a side, angle, and a side. Can we use that somehow? Let's go back to our helpful proof definitions and look for a side, angle, side. And yep, it is that second one. So this is the approach I'm going to do. If I can prove that these triangles are congruent, then it follows that the side is also congruent, okay? So let's go ahead and get writing. So I'm going to assume that ABCD is a rectangle. And my reasons, I guess you can say that this is a given or you can leave it blank because again, we're just trying to paint a picture, okay? So I know that AC, the line AC, is congruent to BD. So again, I'm saying that AC is congruent to BD. And this is true because this is part of the definition of a rectangle slash a parallelogram. Okay. So the second thing I have is that CD is equal to itself, right? So CD is congruent to DC. So what I'm saying that is that this distance from C to D is the same distance from D to C. And that's actually something called the reflexive property. So the reflexive property basically states that if something is true forward, then it's also true going backwards. And then we know that angle ACD, so now I'm going to try approaching these angles, is equal to 90 degrees. Hold up. Well, you can say this, you can say it's equal to 90, or you can say that it's equal to BDC, which is equal to 90 degrees. And this is true because, again, the definition of a rectangle says that they are all 90 degrees. So it follows that the triangle, so I'm going to draw a triangle symbol. So the triangle ACD is congruent to the triangle BDC. So let's recap. We proved that a side's the same, another side is the same, and an angle is the same. So we just proved that these triangles, remember these triangles right here, we just proved that these are congruent. These are congruent by side, angle, side. And if these triangles are congruent, then that means that all of their sides are the same. So then it follows that BC is congruent to AD. And this is just, you could say a congruent triangle definition. Because if triangles are congruent, then that means that all the sides are the same. So let's go ahead and write this down. And again, I'm going to use blue to use as my sentence phrase. So let's say assume. So when I write assume, we're trying to paint a picture, right? So assume A, B, C, D is a rectangle. Then, let's see, what was my first one? We have that AC is congruent to BD. AC is congruent to BD. And why is it congruent? Because it is part of the definition by the definition of a rectangle. And so I got this part done. I got this part done. I'm not here. And CD, so the line CD is congruent to the line DC by the reflexive property. And this is an English class. You can use and again. So, and the angle ACD is congruent to BDC by, again, we could say the definition of a rectangle. I usually say the definition of a rectangle when I'm claiming a property of a rectangle. Okay. So I've basically laid out everything I have. Then, let me use blue. So then, this is where it's almost to my grand finale. I'm saying that the triangles are congruent by what? By side angle side. Then you can say thus, therefore, you can use then again, but I'm kind of tired of it. Therefore, BC is congruent to AD by the congruent triangle definition. And again, we would not be done if we did not use our mathematician a stit symbol. Bam. And that it is it. That's how it's done. Good luck.